Okay, good afternoon, class. Right. So today we will continue for 3.4. Right. So after this, we'll listen next week. Okay. We go to chapter 4. Okay, 4.1. And for the exam, the topic that will come out is until 4.2. Okay, 4.2. But let's say if there's any changes, I will let you know because our exam is starting at 21 November. Okay, so let's see the 3.4. So this topic is actually more to the calculation, right? To the formula, to the derivation of formula, right? And then using the formula to calculate the energy, electrical energy, the power loss, right? So at this topic, right? So you can formulate the relationship between E, right? Electrical energy, voltage, current, and also time. Okay, and you also can formulate relationship between power, voltage, and also current. Okay, and then we have to solve the problem, right? Solve the problem by using all the formula that we have derived. Okay, and also the last one, compare power and rate of energy electrical consumptions. Right, this one is, let's say if you want to, like how much that you need to pay, okay, for the electric bill for this month. So we will try to calculate, right, the electrical energy by using the formula E is equals to PT. Okay, so that one we discuss. And the last one is 3.4.5. So Sarge's way to save usage of electrical energy in household, right? So how you want to save energy. So we start now, right? So formulate a relationship between electrical energy, voltage, current, and time. Okay, so the relationship between electrical energy, voltage, current, and time. So the potential difference, right? So V. So we already know V is actually the total energy. What is the energy that be used to transfer, right, 1 coulomb of charge through the 2 points. So let's say if I have, this is point A, right, and this is point B. Okay, so how many energy that I need, okay, to transfer the 1 coulomb charge, let's say from A to B. So that is called a potential difference. Okay, and what does it mean by current? Rate of charge flow. Okay, then we learn that from Ohm's law. Okay, V is equals to IR. So what is Ohm's law? It says that the potential difference is directly proportional to the current, right? As long the temperature, okay, the temperature is constant and also other variable, okay, constant, right? So V is equals to IR. Okay, so this is the formula for B is equals to E over Q, right? This one we already learned 3.1. Okay, for this part, I erase this one first. Okay, then EV is equals to E over Q, then you already know Q is actually the rate of charge flow, that is Q is equals to I over T. So if I arrange back the formula, right, if I arrange back the formula here, so it's actually E is equals to QV or VQ. Okay, so this one I arrange it back. Okay, so is equals to VQ, right? And you already know that Q is actually equals to IT. So I just replace the Q with IT here. So it become E is equals to VIT. Okay, then after that V is actually equals to IR. So I replace the V with IR. So it become IRIT. Okay, but then I multiply by I, it become I square, okay, and RT. So this is the formula for energy, right? That means V is equals to VIT or E is equals to I square RT. Okay, then after that, from the E is equals to VIT, right? VIT. So this one also you can derive that I is actually from I is V over R. This one come from Ohm's law, right? So that's why it become VVRT. So it become V square T over R. Okay. But in the exam, you have to see what is the information that be given in the questions, right? To know which formula that you need to use. Okay. But for the exam, I think the formula that we give you is only the basic one. It's like maybe they will give you this one. Yes, this one is for sure. And also this one. Also, of course, lah, Ohm's law, right? That one they will give. But other than that, you have to derive it on your own. Okay, so this is E is equals to V square T. So it come from V I is equals to VR come from Ohm's law, right? So we arrange this one. I is actually V over R. So I replace the I with V over R. So V square T over R. So that's the formula. So what is the SI unit for the electrical energy? So basically for the electrical energy, any energy, doesn't matter the electrical energy, the potential energy, the kinetic energy, right? That's all, as long as it says that energy, the unit must be in joule. Okay, joule, right? So what does it mean by joule? So here it says 1 joule is the electrical energy that is used when 1 ampere of current flows through an electrical device with a potential difference of V, 1 voltage across it for 1 second. So the energy that being used, okay, when 1 ampere of current flows to the electrical device with a potential difference of 1 V, means 1 volt, okay, with the potential difference 1 volt across it for 1 second. Right? So means the energy, it must be the energy that be used, okay, when 1 ampere current, okay, flows, okay, in the electrical device with a potential difference of 1 volt, okay, and the time, okay, for it to cross is only 1 second. So that is meant by the 1 joule here. Okay, so 3.4.2. So we already derived, okay, for the energy, right? The relationship between E, V, I, and T, right? Then the next one is we need to derive, right? P, V, and I, okay? So P is equals to VI, okay? P is a power, right? So the relationship between power, voltage, and current. Yes? Did someone say something just now? Oh, no. Okay, so the relationship between P, V, and I. So have you ever seen a label is as shown? So this one, if you buy the electrical appliance, you can see there's a label that shows that how many voltage does it need and how much power does it need. Okay, but in every country, they got their own voltage. So let's say in the Japan, right? The voltage is much lower than ours, right? That one is 220, I think. Okay, so 220 voltage is supplied. So that's why if you cook, they say you bring the electrical appliance, okay, from here to Japan, right? So you will need more time, okay, to cook the rice because the voltage is quite low, right? Because we our like nation we use 240 volt. Okay, so that is actually the difference. Okay, 2000. This one, if you say 2020 volt, 240 means it's okay, right? So this one, it says the label displays the voltage and also the electrical power required to operate the electrical appliance, right? Then based on the label, okay? So I think we already answered this one, okay? And when we do the exercise in the class, right? What does it mean by 200 volt, 240 volt, 700 watt? So it says here, right? When the 240 volt is supplied to the electrical appliance, so 700 joule of electrical energy will be released in 1 second. Okay, so that what it means. This one come out once in SPM, right? They ask you what does it mean by 240 volt, 700 watt. Okay, so you just change this one because this one is watt. Watt means is a power, right? So power is work divided by time. And work, you already know the unit is in joule. It's almost the same like energy, right? The unit is in joule. So it means joule per second. Okay, so means if for 240 volt is applies to the electrical appliance, so 700 joule, okay, energy of 700 joule per second will be used in 1 second. Okay, so this is the meaning of 200 volt, 700 watt. Okay, so this information can be used to calculate the amount of electrical energy that is used over a period of time. Okay, that one by using the E is equals to PT. How many energy that, how much energy that you will need. So the power here, let's say 700 watt, okay, and the time, okay, how many time you use the, how long you use the electrical appliance, okay. So that one we will learn in next part. Okay, so the voltage level on the electrical appliance is the working voltage. Okay, it's the working voltage. So the working voltage is the potential difference required to operate under normal condition. Like I said, under normal condition. Let's say if you go to the country that use the low voltage, right? If you use a low voltage means then you need more time lah to cook the rice. Okay. But let's say it's more than 240, you say you go somewhere that the voltage is supply is like 250, means you cannot use this rice cooker. Okay, so that's the what does it mean, why is need where they put a label here. Okay, but roughly mostly we use 220 and 240. Okay, so the relationship between P, V and I. Okay, so we already know the formula for P is equals to VI. Okay, oops. Right, so what is that mean by power? So P is actually W over T. Okay, means the energy, right? The energy, okay, the energy that being used in 1 second. So the rate of electrical energy dissipated or transformed. Okay, so remember when we learn about the resistance, right? Factor effective resistance. I told you like if there we need let's say we need to have the heat energy, right? So we want the heat energy, so means we have to use the low resistance. Okay, sorry, high resistance, right? If you need the heat or light or something, means you need another energy, so means you need to have the high resistance. So if a high resistance means they will produce high energy loss. So that energy loss will be converted into heat energy or light energy. Okay, so the power is the rate of electrical energy dissipated or transformed. So this is the formula, energy divided by time. Okay, so we already know, right? If E, just now we learned that E is equals to PT, right? So E is equals to PT. Okay, and P is equals to VI, right? So VIT. So that's how they got VIT. Just now we already derived. So E is equals to VIT. So this one no. All right, then this one is actually P is equals to VI. How? Okay, they just cut it off. So they got P is equals to VI. So what is the unit here? Of course, if you want to use joule per second, or you can use watt. So that is the unit for power. Okay, for the resistance, lamps and heating elements, so this one combine P is equals to VR and V is equals to IR. That means for resistor, lamps, heating elements. So all that means they need loss energy, right? Lamps, you need light energy. For the heating element, you need heat energy, right? Let's say for the kettle, okay, for the iron, right? Hair dryer. So that one, if you want to find the energy, we use this one, okay? P is equals to VI, right? Then we derive V is actually equals to IR. Okay, so I times I, you will get I square. So you get R. So P is equals to I square R. So that's how we derive this formula. This is the energy loss, or this one is a power loss. Okay, P is equals to I square R. All right, then for this one, other than that, we also can derive from P is equals to VI, right? And from the Ohm's law, V is equals to IR. So mean if I want to derive I is V equals V divided by R. So I change I, okay, and I got this one. So then V times V square over R. So that's how you got the formula for P is equals to V square over R. And the next one is P is equals to I square R. Okay, but usually for the power loss, we use this formula. Okay, but it depends lah. What is the formula being? What is the info of the questions being given? Okay, now we have to solve the problem involving the electrical energy and power in daily life. Okay, so let's say we have example 1. This is from your textbook. Okay, so figure 3.35 shows a circuit that is supplied with a 6-volt battery. So we already know the V is 6 volt, right? And they says if the current is 0.7 ampere, 0.7 ampere, what is the amount of electrical energy used to light up the lamp for 1 minute? Okay, so this one, they say, you see the unit here. Remember, for the energy, the unit must be in second, except when you calculate the energy, electrical energy for your house. That one, they use a kilowatt per hour, right? That one in hour, okay, because kilowatt per hour. But for this one, is have to be used, okay, you have to use in second. So means the T is 60 seconds, right? So if you want to find the E here, okay, so how do you, if you want to, what is the formula you want to use? Okay, so we know E is equals to PT, okay, and also I know already like E is equals to actually VIT, right? So you can straight away use this one. Or let's say you forgot, right? Because there's too many formula to remember. So what you do, you can just use this one first, because we already know that VIT and E is equals to PT, right? And P is equals to VIT. So I mean you can just derive from there. Okay, you don't need to remember all the formula is equals to VIT. Is that one you already know? You can just derive, okay, on that. Just go and derive, right? So P, okay, let's say I use this one. E is equals to PT, right? So means this one you have the time, but you don't have the power here, right? So you already know P is equals to VI. This is the basic thing, right? So you just remember the basic formula. P is equals to VI, E is equals to PT, another one V is equals to IR. Okay, or and then 4, I think, 4, Q is equals to IT. Okay, so based from the 4 basic formula, okay, then you can find the answer. If you see that there's too much formula to remember, right? P is equals to I square R, okay, and so on, right? So what I do is just remember 4 formula that you see. If then we derive, then we need that 4 formula. So P is equals to VI, this one. This one you already learned in form 3, if I'm not mistaken. E is equals to PT, okay, another one V is equals to IR, okay, and this one Q is equals to IT. So this 4 formula, right, you just need this one, then you can find, okay, you can try to calculate, okay. So for this one, P is equals to VI, right? So V is 6 volt, I is 0.7, so I think you will get 4.2. Okay, so your 4.2 watt. Okay, this one I just put 6 times 0.7, so it becomes 4.2 watt. Alright, so then you just replace in the formula. So we already have P here. The time also we already have, that is second, right? 60 seconds. So 4.2 times 60. So you get the answer. The same one if you just use straightly. But that means if you want to use this one straightly, you have to remember all the formula. Okay, which is I think too many, right? Alright. So you get that one. Okay, 4.2 times 60. So the answer is 252 joule. Okay, so we try to find to discuss for this one. A fluorescent lamp is labeled 240 volt 30 watt. So what does it mean by 240 volt 30 watt? It means when the voltage supplies is 240 volt, okay, the energy, okay, that we use is 30 joule per second. Okay, the energy that will be released is 30 joule per second. So calculate the lamp resistance. Okay, so we have V and V is 240. Then we have W. What is W? P, sorry. W, P. P is 30 watt, 32 watt. Okay. So the lamp resistance. How do we want to find the R here? Okay. So we know that if you want R, you need V is equals to IR, right? Okay, we have V here, but we don't have I, right? We don't have I here. Okay, but we know P is equals to VI, right? So what is your V here? 20. What is your power here? 32. Okay, then you can find your R here, your I here. So then after that, you can just substitute your I here and your V here 240. Then you can get your R here. So this one, your I is actually, you calculate lah 32 divided by 240, we get the answer. Then you substitute in here. So you can see it's actually, you just have to remember that 4 basic formula. Okay, and but this one, if you can remember, I mean like you are already memorize it, it's okay, you can just straight away use it. Okay, and then for B, the current flowing through the lamp under normal condition. So we already know, right? This one, we just divide. So we find P is equals to VI, right? And you can put it this one as the answer. Okay, and the electrical power required. Okay, so E is equals to PT. Okay, and the power we already know. Okay, the power we already know is 30 watt, 32 watt. Okay, the time here. So usually they ask you to change it to kilojoule. Okay, so 3 hours. So remember this one have to be in second. Okay, so this one have to be in seconds. So 3 hours means times 60, 180 minutes, right? And you have to multiply again with 60 because it's 1 minute is 60 seconds. Okay, then you will get 10,800 seconds. So then you just multiply. Your power is 32 watt. Your time is 10,800. Then you got this answer. Okay, so kilojoule. Kilo means what? Times 10 power of 3. Right? Times 10 power of 3. Or you can just divide by 1,000. Okay? So times 10 power of 3 means you need to 1, 2, right? 3. So later it become 345.6, right? Kilojoule. So because it is just same lah, 300. If you divide also with 1,000, you will get the same answer. Okay, so you just jump 3 times because 10 power of 3, right? So you just jump 3 times from the back. Okay, then you will get, where is the, you have to put the decimal point is. So 345.6 kilojoule. Okay, so remember that one, they must be in second, except when they ask you to calculate the electrical bill. That one must be kilowatt per hour because that is the unit we use in our home. Okay. All right. Okay, so this one I just I want to, okay, can compare power, right? So information about the torchlight, light bulbs L and M are given in the table below. Compare the brightness, okay, of the two bulbs when they are used under normal conditions. So what is the comparison? How do you want to know which one is the brighter? You see the current. Okay, you see the current. If the current is higher, it means the bulb will be brighter. Okay, so the bright of the bulbs is actually must be depend on the currents. So how does the current, we want to control the current by using the resistance. Okay, you can use the rheostat, you can use a bulb. Okay, bulb is also like a kind of the resistance also. Okay, so how many joules of electrical energy in 1 kilowatt per hour? Okay, so we use E is equals to PT. So you can see actually the one that we use, E is equal to PT, V is equals to IR, then Q is equals to IT, right? So then we derive, you got another formula. So just remember that 4 basic formula. So how many joules of electrical energy in 1 kilowatt per hour? So 1 kilowatt per hour means E is equals to PT. 1 kilowatt means 1 hour, 1 kilowatt, one hour, 1,000 watt, right? So means for the power here, 1,000, okay? And the hour here, you must change to second, okay? If not, you cannot use joule, okay? Just like when you answer the exam paper, for the energy, let's take potential energy, right? So most of you got it wrong because you don't change, right? You don't change the cm to meter. You don't change the cm to meter. Okay, that's why you cannot use. You cannot have that answer. Okay, so remember, whatever is this, you have to see. If it joules, must be in second. Let's say, if let's say for the force, right? So force Newton must be in meter. Means you have, let's say they give you in cm, they ask you to find the force, means you need to change the cm to meter. The unit is the important part. Okay, so P is equals to P times T. So P is the power. So in 1 hour, 1000 kilowatt. So kilo is 10 times 3, right? 10 power of 3. So 1000, and hour here you have to change to second. 60 times 60, you get 3600. So just multiply, you can get 3,600,000 joule, which is this one. I prefer for you to change it to the to this one, 3.6 times 1, 2, 3, 4, 5, 6. So 3.6 times 10 power of 6 joule. So I prefer for you to change the answer to this one, right? Just be careful when they have the another number at back here. Make sure you round it off correctly. Okay, so this is the example. So an electrical kettle is connected across a 240 volt power supply. So if the resistance of the heating element is 40 ohm, means the R is 40 ohm, then they ask you to find the current flowing. So basically V is equals to IR, come from the Ohm's law. Okay, and then you got the answer 6 ampere. Okay, the quantity of heat produced. So the quantity of heat produced means the energy. So E is equals to PT, right? So E is equal to PT. Teacher, they don't give you the amount, right? The amount of current. So, and then how you want to calculate P? So you know P is equals to VI, right? Okay, V is 240 volt. Okay, P is the R, right? So you can find R is equals to V over I. Then you can find your I there. So you just substitute in the formula. Or you can just straight away use this formula, E is equals to VIT. Then you got the answer. Okay, so let's see the another one. Okay, this one. Right. So the diagram shows 3 light bulbs A, B, C connected to a power supply 12 volt. So calculate the ammeter reading. Okay, so for this one, they use a different bulb. Okay, so means not all the bulb have the same amount of resistance. Okay, but the voltage given for the whole circuit is 12 volt. Okay, so let's see for I1. Okay, so I1 means, I think for this one, right? This one. Okay, so how you want to find the ammeter reading? This one is from here, right? The ammeter reading. So the ammeter is actually give the reading for the whole circuit. That means for this one, after that, then we join back, right? Okay, but let's say they want ask you to find this one, they will just put at this part. Alright, that one if they put here means they only ask for the current in this part only. If they put the ampere here, they just want at this part only. So if this one on this part only. Okay. So you need to be careful where they put the ammeter. If they put here, you already know the current will flow from positive to negative, right? So let's say I give the example. Let's say this one is 3 volt. Okay. So here also must be 3 volt. But then after it come here, it will be divide. Okay. So if divide, it actually depends on the whether the bulb is same or not. This one is not same. So means the current flows between at here, okay, at here and also here is not same. Okay, it's not same because this one 12 volt, this one is 6 volt. They use a different bulb. As long it says use the same bulb, so you that one you can put. They say this one I change the question. It's actually same, right? All 3 bulb is same. So means if there 3 volt here, this one should be 1.5, this one should be 1.5. Okay, then it will flow to 1.5 here, right? Then this one also flow 1.5. But then after that, here that we join back, right? Here that we join back. So this one also we go here and also below also there we go here. So then we join back at here. Okay. So if they ask you what's the reading there, so mean it will become 3 ampere. Because they're joining back from here to and to go, right? This one also, they say, I've said use the same bulb. So 1.5, this one also 1.5. You can just divide, but different bulb cannot. Okay, have to calculate one by one. Okay, so 1.5, this one also 1.5. So after that, when it goes here, okay, and then this one also goes here, right? So then we join back the current. Okay, because we know for the parallel circuit, the current is not the same, only the voltage, right? Okay, so then it becomes 3 ampere. So same as this one also. If you put here, right, they're still not divided. So it means this one should be 3 ampere. Okay, so I1, so 24 divided by 12. This one come from what? P is equals to VI. Sorry, VI. Then I is equals to P over V. So that's why 24 divided by 12. This is the first one. Okay, for the I2, okay, for the I2, you see 12 volt, right? So 12 volt, 6 volt, 12 watt. So again, same formula, power is 12, voltage is 6. So you will get 2 ampere, okay? And this one, because they are series, right? So mean this one, if they got 2 ampere, this one also they will get 2 ampere because they are in series. So this one 2 ampere, then go here, right? So we already calculate for I1 also 2 ampere, right? So this one also I2 also 2 ampere, right? So what is the current that they will get? 2 times 2 at here. Because I said just now that we combine back. Okay, so at here they will split. Okay, then they walk here, then go here. Then this one also walk here, go here. But then at here they will combine back the current. Okay, so that's the answer. So 2 plus 2 is 4 ampere. Okay, diagram shows two resistors of 1 ohm and 2 ohm connected in series to a 12 volt battery. Okay, so usually we put it 12 volt because you already know if you put it parallel, right? If you put the battery parallel, the amount of voltage same. Let's say if I put 12 volt, 12 volt, 12 volt, right? Let's say I put this one like this. Okay, the battery is like this. So you will still got only 12 volt, right? So we still get only 12 volt because this is parallel. So parallel, the voltage is same. Okay, so 12 volt. So that is the example lah. So it just shows two resistors of 1 ohm and 2 ohm. Means this one different resistance. Calculate power dissipated by each resistor. So this one we use P is equals I square R. So I square R, I you need to find, okay, by using P is equals to VI. Okay, P is equals to VI. Okay, so I is equals to P over V. Right, then after that, you got 4 ampere or I is equals to VR. This one they use I is equals to V over R. Okay, for this formula. I is equals to V over R. So the R is what? The effective resistance here. This is series, right? So you just need to add 2 plus 1. So you will get 3. So that's why you got 3 here for the R. And for the V, they already give you is 12 volt. So you just put it 12 volt. So the current flows for the circuit is 4 ampere here. Okay, then after that, this is series, right? So means this one we get 4 ampere and this one should be also 4 ampere. Okay, because series, that's why you need to know the characteristic of the series and also parallel circuit. For series, they have the same current. So means this one, if you get 4, this one also should get 4 because the current is same, right? Then you calculate one by one by using P is equals to I square R. Okay, your I already calculate here, 4 square times 1, you got 16 watt. P is equals to I square R, 4 square times 2, we get 32 watt. So means the power dissipated for P is 60 watt and 32 is Q. Means the power released to the surrounding, okay, or joule per second. 30 joule of energy per second will be released to the air. Okay, that is for the series. What if you change it? We put it in parallel. Okay, so if you put it in parallel, okay, what you need to do, you want to find what? The power dissipated by each resistor. Okay, so here we have P is equals to V square over R. Because now the internal resistance is 1 over 1 plus 1 over 2, right? So you will get 12 square divided by 1, okay? And you got 144 watt, okay? So for this one, we combine it to make it become 1 resistant, okay? So this one is actually, if you want to find the current, you can use the IV over R first to find the current that will flow throughout the circuit, okay? Alright, so this one is actually that I promised to you, okay, how you want to calculate. Okay, this one come out in the exam. Sometimes it's come out in paper 1, the objective part. Sometimes it come out on the structure also can, AC also can. Remember, you have 5 marks for the calculation. Okay, I think for section B, if I'm not mistaken. Okay, section C, no, they don't have. Okay, section B. So for 5 marks for the calculation. So remember in the exam, the one that come out is to find the pressure in water, right? So you use P is equals to H rho G, right? So that one. So if they come out for the electrical energy, because electrical they got too many formula, too many calculation. So mean that anything can come out. Okay. So complete the table by calculating the energy consumption. So we use this formula. Okay, but okay, this one, the power must be in kilowatt. If they want you to calculate the power, or you need to find the what is the electrical energy that you use at home. If that means it's not from home, right? It's not for the home, it's just like a normal calculations, then you don't need to change. But they say if you give you the electrical bill, they ask you how much energy, then they ask you how much is your bill for that month. So that one you need to change, because because in Malaysia we use a kilowatt per hour. Because if you change it to watt per second, of course lah, right? You know that the amount is too big, right? So we change it to kilowatt per hour. Okay, so for this one, they give you, let's say, fan. Fan, the power rating is 50 watt. All right, 50 watt. What does that mean by power here? It means the energy that will be, power is actually the energy that being released, right, in 1 second. Okay, so this one, the time is 1 hour. Okay, luckily lah, they already change it to hour. If they give you a minute, then you change to hour. How you want to change? Divide by 60. Okay, so this one 50 watt. But I said just now, if you want to change it, if you want to use it, you want to calculate your bill, that means you need to change it to kilo. So how to change to kilo? By divide it with 1000. Okay, so you get 0.05. Okay, then after that, here for the time. Okay, for the time already in 1 hour. So no need to change. So just multiply it by 1, you get 0.01. Teacher, let's say they give you 30 minutes. They didn't give you in hour. They give you 30 minutes. Change to hour by dividing with 60. So you got like 0.5 hour, right? Then the time is 0.5. Okay, so change to hour first. And this one 100. Change to kilowatt by dividing with 1000. You will get 0.1. But the time is already in hour, no need to change. So that times 1, you got 0.1. Okay, and then the computer, okay, the power need is 200, okay, in watt. But change it to kilowatt by dividing it with 1000. You get 0.2. Then times 1, you get 0.2. Okay, and the air conditioner, okay. So this one is 1000. So means you need to divide it with 1000. You will get 1. Okay, 1000 divided by 1000 is 1. And the time hour is 1 also. So the result is 1.0, okay, kilowatt per hour. And also washing machine. So 1800 divided by 1000. Okay, so you will get 1.8. But this one is half hour. Change it to decimal point. Teacher, if I want to do, I just put it in the fraction. Yes, you can, but remember at this part, no fraction. Please, no more fraction. Okay, don't do any that kind of mistake anymore. Okay, so remember, no fraction, only decimal point. Okay, and you round off. Let's say they give you a lot decimal point, just round off it to 2 or 3 decimal point. Unless the answer given you exactly 0.9, no more, no more decimal, no more the number, there's no number at the back of it. Okay, then you can take 0.9. But let's say it's give you a long number, then you need to round off to 2 or 3 decimal point with the unit. Okay, then we got so this one, they calculate for the month, for the cost of operating appliance in month of April. Okay, so again, E is equals to PT, right? And your P is your power, is already converted to kilowatt. So just straight away use it. 2. If they didn't convert, you need to convert first by divide 1000. Okay, and then they use it for 10 minutes. Okay, so I told you kilowatt per hour, right? So means 10 minutes have to be divided with 60. Okay, I understand. If you divide 10 over 60, you will get like 0.666, if I'm not mistaken lah, right? So if you, no, if that one is 2 divided by 3. Okay, so I think 0.1666666 like that, right? So that's why I said, if you do this one, this problem, don't put it in this decimal point yet. Leave it in fraction. Leave it. Okay, then after that, you calculate using your calculator, you can get the exact answer. Because if you round off here, right, so you get what, 0.17. Okay, so your answer will not, you cannot get 750, you can get 7.52 or something. So now your answer is different. So at this part, yes, during to show the calculation, your work, okay, your step, okay, yes, you can use the fraction, but the end answer mean the last answer must be in decimal point. So this one, 10 over 60. Okay, we change it to hour. Okay, then we times 3. Okay, why it times 3? Because they use it 3 times a day. Okay, 3 times a day. Sometimes they say using 3 days. So you have to time by 3 lah. Right? So this one 3 times a day means 1 times they use 2 kilowatt per hour. 2 kilowatt in 10 minutes for once. Okay, then after, so means like it's actually like 30 minutes, right? Okay, 10, 30 lah, kan? So 10 over 60 times 3. Okay, because 3 times per day. Then how many days? For 1 month. So April got 30 days. Okay, so 30 days. Okay, then times 0.25. Teacher, why not 25? If you put 25, that means 25 ringgit. So 25 cents means 0.25. Don't put it this one wrong. 0.25. Okay, change it to the same, right? Okay, and then you got the answer. Okay, so PT. So means the P is no problem. Actually the time, right? So the time here from 10 minutes, okay, change to hour, and then use 3 times. Okay, so 3 times a day. Then how many days? All right, 30 days. Then after that, multiply, you got the answer for the energy. That one is kilowatt per hour. Okay, then you multiply with 0.25. Then you get 7 ringgit 50 cents. So don't forget the unit. Okay, so what I will do now, okay, we still have like 40 minutes. Okay, so I want you to try to answer. This one you can just read it on your own. Tomorrow, there is a change of time. Okay, I will start around 10:30 until 11:30. Okay. Yeah, and I'm sorry because I absent for the whole week. Okay, my blood is kind of high. Maybe because terkejut kan, tiba-tiba exam kata bulan 10. Cikgu yang stress. And I think I want a feedback lah. Okay, let's say the monitor for 5S, 5M and 5K. They say they are not here. You tell them, right? Because when I see all the papers you give me, I want to compare what day, right? You can come. Then I just know that sejarah also do extra class, right, after school. So I don't want you to feel like pressure, right? So I want to make it like the online class, but I will give you the material, of course. Okay, the material we give in the school, then we discuss it during online. So I just want like at least like once per week. Okay, not during this part. Yeah, this one is actually I use it to finish the syllabus. Okay, I want only like not too long, like only 1 hour 45 minutes, so we can discuss at least we got something. Okay, because I see your timetable Isnin got sejarah kan, and then this one later got carnival lah whatever kan, so it's hard for me to do it with you. Okay, but this is important. Okay, so means I want the your class to choose any day, okay, during night ke, weekdays ke apa, terpulang lah. Okay, so you decide what day. Then we do it online, we discuss online. At least we got something. Okay, rather than we just doing nothing, right? So I want you to practice to answer the exam, especially the paper one. You are very weak in the paper one. Okay, and I'm doing the set for the paper one actually now. Okay, and also the meaning. Okay, the meaning for each definition, the principle, all that. Okay, so it will I just to help you lah. Okay, so the monitor please decide and please tell me. Okay, that next week. Okay, I want to do it early. Okay, so the code. If anything, you can just text me 31478. 31478. 31478. If the monitor is not here, so someone like tell your monitor lah for 5S, 5M and also 5K. Okay, this one I just give like how many minutes? 2 minutes. So for those who want to join, please join. Okay. Try to join. Okay, 2 minutes. No one will join, only 9. Come on, join lah. Lama kan tak PDPR. Of course you miss, right? You miss the time for PDPR. During PDPR kan kita selalu guna class point. So mesti rindu kan nak PDPR, duduk kat rumah, boleh bangun lambat kan. And to next week you have lisan, right? So means if you don't have lisan that day, do you need to come to school or not? Anyone? Do you know? Or you don't need to come for the whole week? Tak ada orang tahu. Kau percaya ni? Oh, need to come. Oh, okay. I thought like last year they said no need. Oh, this year need eh. Good. I agree. So means you need to come. Okay. Because I thought no need to come. This one is the calculation. Okay, so try. We try to answer number one and number one first. I give you not that much time, like maybe 2 minutes. Oh, kena datang kan. That's good lah. 2 minutes. Number one only. Oh, four people already answer. 2 minutes, I will close. Okay, 20 seconds more. Okay, done. Okay, for number one. Okay, thank you for those who join. Alright, so for this one, electrical bulb is labeled 240 volt, 60 watt, right? So how much energy is used by the bulb in 1 minute if the bulb is connected to a 240 volt supply? So P is equals to VI. Okay, actually for the energy, we know the formula is equals to PT, right? So P is equals to VI 240, right? And the I also, the I we don't know. P is equals to, I we need to find lah. Don't know pula. Right? So it become like that. 1 over 4 is 0.25, right? 60 divided by 240. Yeah, 0.25. Then you can get the current 0.25. Okay. Then we already know, wait, why do I need to use this formula? Right, they'll give you the power, right? See, what's happening? So 60 times the time is 1 minute. 1 minute, 60 seconds. So 3,600. The answer is D. Right. Okay. If I show this one, you will get the answer straight away. Okay, never mind. Try number two. Now we check your answer. A fluorescent lamp is used in a normal household. Okay, has a power of 40 watt. P is 40 watt. If the cost per unit of electrical energy is 20 cents, so what is the cost of switching on the fluorescent power lamp for 20 hours? So remember this one, if they ask you to find the cost, to find the energy, okay, for the house, right? Electrical energy for the house. So remember your watt must be in kilowatt, must be divided with 1,000. So E is equals to time. So the time and also 20 cents 0.2. Okay, 20 minutes, 20 seconds. Okay. Okay, so let's check. So this one I already changed the power to kilowatt. Okay, and then the hour, right? How many hours? 20 hours. Okay, so times 20, right? The time must be in 20 an hour, right? So 20 hours. Okay, and then the time is, sorry, how many cents? 0.2. Okay, so you just multiply 40 divided by 1000 times 20 times 0.2. You will get like 16 cent. Yeah, 60 cent only. Okay, for 20 hours. So macam tak, kalau kat Malaysia tak lah kan. So BD, DB. Oh, this one is the second one. Okay, C, no. Number one is, yeah, D. Right. A, no. No, no, no. Okay, so I will continue this one during class. Then we go to 4.1 electromagnetism. Okay, so see you tomorrow. Tomorrow 10:30 until 11:30. Okay, for chapter 4, I will not do it online because I need to show you all the law, right? Fleming's and rules. So it's hard for me to show you if during the online class. So we will straight away go to chapter 5, and the chapter 4 we learn in school. Okay. So see you tomorrow 10:30. Okay, thank you class. All right, using the same link. Okay, so bye. Take care everyone. Welcome.